was something I was going to bring up anyway. Well, hey, everybody. Welcome again to Astronomy Daily Live. It's 2 hours UTC, and it's time again for the live stream where we sit here in sort of a, circle of friends, sort of a virtual porch, and we grab our consumables of choice and sit around and just sort of chit-chat about all things astronomy for a while. Astronomy, space. Forgot to turn off my YouTube again. I was doing pretty good there for a while. There we go. Okay. So yeah, it doesn't just have to be limited to astronomical topics, right? We're talking about space. We're talking about, light and radio and a nice broad array, mainly astronomical, but tangents are allowed. So we were just talking in the pre-show about the Soyuz. I guess you'd call it a launch failure, where something happened. Something happened after the initial launch, and sometime after those first 4 engines come off, something happened, and even the video looked a little strange. So yeah. The other thing I noticed was there was, for a brief amount of time, there was video in the cabin, right? Showing the 2 astronauts there, and there was a moment right in the front of the field of view. There was this dangling stuffed something, and it was most definitely pointing down pretty hard, right? So I'm thinking high G's, right? And then all of a sudden, that dangling stuffed animal sort of went weightless, and then just went all over the place, and both of the astronauts started shaking like violently, right? And when I saw that, I was sort of like, I wonder if that's normal or not. And then it was right after that when the Russian translator started saying the word failure over and over and over again. And I'm like, wow, But then they switched to that graphic, that CGI graphic, showing sort of the pre-planned path, and it was showing a beautiful launch, right? Going along well, and then there's this translator saying failure over and over and over again. It's like wow. So yeah, that's pretty interesting. We'll see what's going to happen with all of that. Tom or Bobby, did you want to say anything else about that?
I didn't watch the launch video, but we'd love to watch it again if it's still available.
Oh yeah, I think you can find it. I think I saw one. I don't remember if I kept a copy of it anywhere, but I did see it. And I agree with what you were saying, Cosmic, about the broadcast. They were reporting everything was normal, everything was going well. And then I even thought I heard somewhere in there somebody say the astronauts reported weightlessness, and then they basically cut from the live stuff to their animated display while they were trying to figure out what was going on with the rocket.
Yeah. So yeah, there some pretty odd things. There was also some kind of mention of the it's not called the abort rocket, but the what's that called? The it's on top, right?
Was that the escape, the capsule escape?
I guess so. Yeah,
Something like that. Yeah.
That had been jettisoned, and that was a little weird too. So yeah, I don't know.
Yeah, they got rid of that about a minute and a half in, and it was a little over 2 minutes when something happened with stage 2, stage 1.
Oh, okay.
Transition. Yeah.
So yeah, that's sort of another mystery, right? Is it's like, okay, if sort of the escape system, sort of wasn't there, how did they escape? I don't know.
Well, I think once they get to a certain altitude, they can just get
they're ballistic?
Yeah, they can get the capsule off of the rocket, and they've got enough time for the parachutes to do the job.
Gotcha. So yeah, they're just there's like a cannonball at that point.
Right. Uncle Bill Doran was talking about the Soyuz and stuff.
Okay, cool. I need to. That's one thing that I forgot to do was grab my chat. So let me do that really quickly. So what do you think is going to happen next? I mean, Soyuz is grounded. So I mean, what does this mean?
And there's no plan B either, so you're screwed.
Well, they need to find out what went wrong and see if it's something that's obviously correctable, some kind of a simple failure to look at, or if it's something more complicated, then that will determine how long they're grounded. And if they're grounded for more than 3 or 4 months, the mission may have to be extended that's going on, or they may have to bring everybody down and have an empty space station.
Yeah, and from what I've heard,
I think what you're saying is true. They do have a backup vehicle if they have to evacuate the space station for a little while.
Well, yeah, they have I think at least 2 up there right now. I think at least 2. There's maybe 3. So getting down, no problem, right? I mean, problem enough, but it's they don't really have to necessarily delay leaving. Of course, the problem with leaving is that eventually you don't have anybody up there, and at least like I said, from what I've heard, without almost like constant maintenance, the space station just is going to fall apart. So yeah.
How many members are on the space station right now? Just 1?
I think there's 3 right now, isn't there?
I don't know. Tom, what do you think?
I believe that's right. Yeah, I believe there's 3.
Yeah,
there were 5, and they brought 2 back.
So I'm thinking if they should have some time, but you're pretty much, if you can't get more people in there, you're pretty much screwed.
Yeah. It's so yeah, it poses a problem, but like I said in the pre-show, if it is a simple thing, right, like oh no, we forgot to tighten the bolts, right? Then if it's a simple thing like that, and I need to look at my chat, that's why I was distracted there for a minute. If it's something,
it's not like a big crazy. If it's just like just one thing,
yeah,
there should be no chance of being having a crew member being fired or something.
Well,
but if it's complicated, well, something's going to happen.
Yeah, I mean, my understanding of rocketry is that there really isn't anything simple. I guess it's that's sort of a relative term, but so I mean, I'm sort of exaggerating in terms of bolts being loose and all that kind of stuff, but if it is something simple that was like he did this and it was supposed to be this, right? Maybe that's all it was. And
it's like every time there is a disaster, either up in space or just like what happened to Challenger in Columbia and stuff, then you don't have a plan B. But I think there was a plan B when the Columbia tragedy struck and they were using the Russian stuff.
Yeah, well, after Challenger, they actually was it? No, it wasn't Challenger. It was Columbia. After Columbia, there were only flights to the space station because they changed. One of the things that they did, which actually was actually spectacular to watch, right? But as the shuttle got close to the ISS, it would do a complete spin all the way around, and they had cameras on the ISS taking high resolution pictures of all the tiles on the shuttle, right? Because that's what got Columbia. Was that at launch some foam or some ice smashed up a bunch of the tiles, and they nobody knew, right? I mean, the entire time in space, they were up there for like 9 or 10 days, I forget exactly. Nobody knew, right? Because you couldn't look. They weren't going to the space station that time, so nobody looked. But after that, after return to flight, they had to fly up to the station, do this rotation thing, check it all out, and then they come in. And I mean, I think that's great. But after that, right? I don't think they ever went back to the HST. I think it was all to the station. I think that was it. Yeah, I don't know if they ever went back to HST or not. Does anybody, Tom, do you remember if that's true or not?
I don't remember, no.
Yeah, I don't either. But regardless, I thought that was great. Them doing that 360 in space. That's like 2001: A Space Odyssey. It was great. It's absolutely fantastic. So, but yeah, they did that every single mission. Pretty sure after that.
Yeah. And I was like, how did the ISS foul up Columbia, or something fouled up Columbia?
No, Columbia, the left side, the left wing, right in the front, when they launched, right, a bunch of foam and a bunch of ice fell off of the external tank, and at the time that foam and ice hit, it was traveling something like, I think I want to say 500 or 600 miles an hour or so. So it really smashed the tiles up, right? I mean, it damaged the tiles, and during reentry, you do not want to have a damaged tile. You just don't. I mean, anywhere. Just so happened to be on the wing, and whammo. So yeah. So yeah, this Soyuz thing is sort of problematic, for sure.
And Uncle Bill Doran says that it has a long rival history.
Yep.
And Roscosmos is not NASA, Therefore, he really doubted it will be grounded long. You don't want to sell Russians very short.
Okay. All right. Yeah. If they're like, so what? We lost one. Let's do another one, right? And maybe that's what they'll do. I mean, that's fine. They can do that. It's like, we know, let's just launch, right?
And they don't. There's no plan B and stuff. So unless they have a plan B, I don't know.
Yeah, I mean, Soyuz is it right now. So yeah. In terms of manned missions. So yeah. I've also got the coffee here. Cheers. All right. Well, cool. Well, I'm glad everybody's in. Atta, I see you over there in the chat. Nice to have you here. Uncle Bill, as usual. Awesome to see you, chat. Switch to live chat. Yeah. Thank you, sir. Man, just barking.
Totterbert, welcome.
Hey there,
does
Totterbert.
SpaceX have any manned capsules?
They are in the process of making one. They are, and is Boeing doing one? And is NASA still working on the Orion capsule? Is that supposed to be manned? So, I mean, if I'm right, I think there's 4 in the works, and then there was Soyuz.
And like I said, there's no plan B yet.
Yeah, who knows? What's that, Tom?
Yeah, I was going to say, yeah, you're right. NASA is still working on Orion. SpaceX is working on Dragon 2. And Blue Origin is working on something. I don't think they're ready yet for anything but those low Earth kind of touristy things. But
yeah, in fact, New Origin is working on now I just forgot what I was going to say. The first one that they're working on now, the suborbital, but they're working on an orbital, which is going to be the New Glenn.
So Uncle Bill Duran, even if the current booster version has a fatal flaw, they will have an older version they can make ready in a hurry. And that's what the point he actually made about Soyuz history.
Cool.
Is if the new version fails, they can just go ahead and downgrade. And there's a potentiality of a plan B.
Nice. Yeah, that's a good point. And I guess it depends on if they have any of the older ones or not. They probably do. Yeah, that's an interesting point. That it's like, okay, this new version, we forgot a couple of bolts. So let's go back to the previous one, which we know works.
Yeah. So like if they just lost their if they just lost their nuts and bolts, they can just go back.
That's right. Well, yeah. So maybe it's not as bad as at least I sort of initially thought. But yeah, I would definitely like to know more of the details of the accident itself, right? Exactly what failed, the sequence of events there, and then how they escaped, how they,
Totterbert, I believe the Russians are a bunch of big dummies.
All right. Well, cool. So yeah, we'll have to keep our eyes and ears open there to follow up on that a little bit. It's I mean, we're all totally into space here, so I mean, it's always really disconcerting and worrying and nerve-wracking, right? When something goes wrong. Even though I mean, it sort of depends on how you measure the outcome, right? I mean, lives saved. Yeah, I think that's probably a good thing.
I didn't know we was smuggling engines from the Russians.
Oh, yeah.
Check the history on those. They were collecting dust by the hundreds in warehouses when the wall fell.
Oh, okay. Yeah. All right. Yeah. Yeah. The Russians have some pretty good engines over there for sure. Sure. So yeah. We'll keep an eye on that story. Definitely want to try to see if I can get a hold of the final report, because then
And if somebody can direct me to that video and maybe put it on the Discord, since I'm using my my tablet to check the chat and stuff, and maybe I just put it on the Discord, please.
yeah, I think you know what, Bobby, I'm gonna post one that I watched. I think it was today. I'm gonna go to my history here, so bear with me for a second, and I'll set you straight here. We'll just sing a song while we're waiting. Let's see. Where did I see it? So it's a video by Scott Manley, and I will post the link on the chat here.
Post it on the Discord too, please.
Oh, okay. I will post it in both places. So copy. And let's see. I'll put it on the live stream chat since I forgot to post that. Okay, so there it is on the Discord. And here it is in the chat. Bam. Okay. So yeah, that was a pretty interesting one. And yeah, when I watched the replay, I watched it.
Yes, Bill Wink, you're not a ghost. You are visible. Welcome aboard.
Who's invisible? Ah, Bill Wink, you are visible. Welcome, welcome. Nice to have you here. We're just talking about the Soyuz rocket failure the other day, and yeah, what that sort of means for the future of the space station and all that, and yeah, I guess it sort of depends on what went wrong, and if they can just sort of go back to a previous version that worked. Yeah, I don't know. They could be up really quick, because the concern there is that they'd have to do an abandoned station thing, and that would definitely suck. That would definitely suck. All right, so we've been looking at various objects in the constellation of Cetus. That was our constellation of the day. Wow, it's been a few days now, but it's a big constellation, and there's lots going on. Lots going on. There is Myra, which is a very nice variable star that it's got like a 300 and some day long period where it gets bright and then dark and then bright again. And we are coming up on a maximum of Myra when it's actually visible to the naked eye. But in 6 months, you're not going to be able to see it at all. So kind of neat. Nice planetary nebula in there, NGC 246, which has a central star that that is a visual binary star. It's actually two stars that sort of form the center of this planetary nebula. So that's a little, I think that's a little strange, a little weird. And then there's a flare star called UV Ceti. And this is like a 13th magnitude star normally, but once in a while, sort of, from what I understand, sort of randomly.
And before you continue, Bill Waite's got doubts about the ability to travel far from Earth. With the radiation, weightlessness, and everyday health problems could easily be fixed on Earth, the whole business seems objectively doubtful.
Yeah, I think Bill, we will find out. We really haven't really spent, I don't think, enough time in sort of free space, right? I mean, being in low Earth orbit is I don't really think very much like being in actual space. I think we're still very, very protected, yeah, I'm not quite sure what we're in for out there. So what we're going to have to do, at least, right, is go out there and sort of see what happens. See what happens. Yeah.
There was an experiment one time about staying longer, like on Earth orbit and stuff.
Well, like I just said, staying in low Earth orbit, that's really not. It's not really in space, right? I mean, we're basically, those objects are in free fall, but they have enough horizontal velocity such that they don't actually hit the ground.
Loss is an issue in space.
Yeah, and this is fine for a really, really, really long time. I don't know about you all, but I don't really hear a lot about what's going on at the space station. I mean, it is a designated national lab. At least the U.S. portion is. I mean, it's a national lab, which carries a lot of meaning, right? I mean, it's not just this metal box that they're doing experiments in. It's an actual lab, right? That has certain procedures and all of that. And one of the gripes, and I mean, I'm guilty, right? I mean, I haven't really looked all that hard, but I would think that there would be a substantial amount of effort to publicize that work.
Okay.
And if anybody's going to hear about it, I mean, I definitely will, because I try to pay attention at least, right? I mean, I may not be actively looking, but I'm actively paying attention. And I don't.
Bill Link, he retired from anesthesia. After 30 years, I can think of a number of problems that are minor here, but it would be awful if, while surgeons are in anesthesia, to fix it. I don't mean appendices or such.
Yeah. I think eventually all the services that we have on Earth, we're going to need wherever we put ourselves. Be it in orbit, be it somewhere between the Earth and the Moon, be it on the Moon, be it on Mars, whatever. We're going to need every single service that we have here, and of course that includes doctors and nurses and all of that. Cheers.
So So our species involved in gravity. It is natural that our health requires it. And Tarbert says robots will be critical in all extrasolar activities, and that's a lot of continuing even on Earth. Bone loss is a problem if we do not weight bearing exercising. We need, and Bill Lincoln kind of concurred that we need everything.
Yeah, yeah. Atta, my understanding is that the astronauts in the space station spend 2 hours a day doing all kinds of exercises. Yeah, because yeah, they've noticed all kinds of physiological things. Um, and I think and this is just sort of me, but I'm sort of wondering if there are a lot of negative things that they find out that they just don't want to talk about, right? So they don't. I don't know. I don't know. Or if a lot of experiments are failures, I'm not exactly sure. So I mean, uh, does anybody else notice that, or is there a source for finding out what is going on at the space station lab? Either the U.S. side or the Russian side or both. Is there any place to find out, like news?
I don't know. You got me on that. But
Yeah.
have
Yeah,
you
I
ever
don't know.
seen? Have you ever seen Wally?
Have I ever seen Wally?
Yeah,
I don't know what that is.
Wally is that little trash bot that were just run down with all the garbage from up in from down in the ground and up into space, and then they had that robot that's sent down from a little space station, and she was actually responding with some form of vegetation on Earth to restore the Earth, and and whenever she found it, that's when the journey really began from Earth to that little space station.
Huh? Is this like a movie or something?
Yeah, it's a
Oh,
movie.
okay, okay, yeah. No, never. I don't think I've ever heard of that one. Anyway, Tom, you were going to say something?
I was just going to say that I hadn't run across any place that shows all of the results of the science that's going on there. The only things I've really heard about are the things we've mentioned here, the bone loss, and Bill is mentioning the vision changes that have occurred with the astronauts on the space station. But I haven't seen any place that really goes into detail about all of the experiments they're doing.
Yeah, and I'm curious about why, right? Because I mean, I would think that they would want to share that kind of knowledge, but as I said, I mean, maybe it's a negative me. I don't know, but maybe a lot of the results are just like bad. It's like, oh no, well, let's let's just not talk about that.
And
It's like,
that's why we probably may never colonize space.
well, yeah, I mean, if it turns out, right, that the space environment is particularly nasty, um, maybe not. The thing of it is, though, right, is that if you can get yourself into a place like on the moon and go underground, you're probably okay, right? Same with Mars.
Yeah.
Same with an asteroid. If you can sort of get,
And, Bill
some,
Wink, your scientists don't drain for one thing. Having all those secretions backing up is a set up for an infection.
yeah, wow, it's things like that, Bill,
So
that
I'm thinking we can have consequential choices if we go like if we like like send a rocket up to Mars or to the moon and stuff, and then all these adversity things is happening and stuff.
Well, either that or, set up a situation where you have the artificial gravity, right? Have some kind of rotating structure, and you live on the outside of that, right? But
Yeah, that's what I was thinking about. Like if you do have artificial gravity, you might have a better chance of doing it.
yeah, yeah. Problem is that those structures have to be really, really, really big, because otherwise you feel the spin. Your body is really sensitive, right? And so uh, you have to have a very, very uniform gravitational
Yeah.
field.
Now I'm
Because
not
if
sure
you're,
if you saw the sci-fi comedy called Rocket Man.
uh, you know, is that the guy who builds the jetpack?
No, that's the Rocketeer. The
That's the
Rocket Man.
Rocketeer. Ah,
Rocket Man was actually were people that were going to Mars and stuff. And what happened? One of the crews got injured, and the one that's a computer programmer got replaced. And they all went to Mars and stuff. And they got a good chimpanzee too, which I think he's pretty funny too on that movie.
cool. So yeah, so we
And
need.
they use a form of artificial gravity on it too.
Okay, cool. Yeah, it just has to be big enough in order for us not to feel the spinning part. And the problem with that is that it has to be like really, really big. I don't remember exactly, but yeah, I mean big, like well, at least I think several hundred meters, right, in radius, I think. So yeah, it's just, I mean, we're not able to do that yet. We can barely keep this little space station going. So yeah. So they have to be big. But I mean, once we're able to do that, then some kind of an artificial gravity. I think that'll solve a lot of problems, right? Because like Atta
Think of
said,
how dizzy you get on a playground merry-go-round every time you move your head, and that's what happens when you make it too small.
yeah, exactly, right.
I like to thank God that I don't get hurt or injured while I'm in that merry-go-round stuff.
Well, you just got to hang on, see?
Yeah. I mean, like, some people like to do it, like, so freaking fast, and then, whoa, boom!
Yeah, I actually like those merry-go-rounds. Those are pretty fun. So, but yeah, they are. They can be dizzying. And
More from Bill Wink. Our ears and vestibular systems have been designed for Earth, not just one of the most disabling conditions.
well, and
So, Uncle Bill, it depends on the G level you want. You need rotation less than 2 RPM. So get to 1 G, that also means a big structure.
yeah, exactly. Oh man, I forgot what I was going to say about that. So yeah, I think doing the artificial gravity thing for sure will improve our chances really, really, really well. I was going to say something about being in free fall. I don't remember now. All right, well, cool. So yeah, somebody put us completely off on a tangent there, which is great. But yeah, I don't know how we got onto that. I like it. What we were talking about, at least what I was talking about, was Cetus, the constellation Cetus. And I'm looking at the chat again here. Yeah, that's correct. Very, very correct. And I got to the flare star UV SETI, and this thing is brightening by oftentimes many magnitudes in like seconds or minutes. And I was thinking last live stream I was looking at the magnitude, and it said it was like 13th or so, which is pretty faint, but I sort of thought that I could see that with my scope, with like a 2-second exposure, and yeah, it turns out that I actually can. I wanted to check that because I was like, oh, I'm not sure, I'm not exactly sure. So what I did, and I'll share my screen for the first time tonight. 41 minutes in and haven't shared the screen yet. Oh, sorry about that. You gotta stare at me for 41 minutes. That's pretty torturous. So what I did is I grabbed, I'm gonna maximize this, I guess. Oh, it already is maximized. This one. Nope. Oops. All right. His navigational skills are, here we go. Okay, so this is a 2-second image taken with my scope, my CCD camera, of the region around NGC 7243, which is a open cluster. I don't remember exactly where it is. So yeah, this is a 2-second exposure. So you can sort of see, the field here. This is about 12 arc minutes on a side here. So it's a pretty small field of view, but the focus was really good because I was using my Batinoff mask, and so I was able to focus really well. And so I went over to Gaia, and I grabbed the same field of stars there. And so what you're seeing here, and I'll sort of zoom in a little bit here. So what you're seeing here is two different colors of stars. The red stars are all the stars that are either brighter than 13th or fainter than 14th. So, all of these big guys here are bright, and then you see all the smaller ones here are faint. All the green ones are the ones between 13th and 14th magnitude. So that is the same brightness as UV SETI is when it isn't flaring. So if you put these side by side, which I will now attempt to do, I'll sort of get you situated here because there's a little bit of rotation going on that's not exactly intuitive. But you see these two stars here? That's these two, right? And then here's this one here, and this one here, and this one here, sort of forms a triangle. So here's these two, points right to this one. And then there's this one here, and this one over here. So now you're seeing that it's basically sort of flipped. You can see these sort of line of stars here are these stars here, right? And then let's see, going off this way. Well, I guess we can't see the whole thing. Anyway, so if you look pretty carefully, what you'll see is, and I'm trying to do it here again. Yeah, is there's this star here and this binary star here. Oh, does that make any sense? Yeah, it does. And here's a green one here. So that's like a 13th magnitude star. Well, that's that one right there. Right? Because here's the binary. Here's this guy and here's this guy. So these two sort of point to our 13th magnitude star. And that's what this guy is right here. So that's pretty bright. That's enough signal that I'm going to be able to get some kind of light curve off of it. So you can sort of see here too. Let's see, there's another one over here, right, which is this guy right there. I think it's either that one or, yeah, it's hard to tell exactly which one it is. But yeah, so I'm definitely seeing 13th magnitude stars with a 2-second exposure, which unfortunately is about as long as I can go. I'm still having some tracking problems with the mount, which may or may not ever go away. I'm going to have to get a different mount, or I'm going to have to upgrade my camera system to be able to properly track. But at the moment, what I've got is working well. So yeah, this guy looks like he's pretty close to 13th, right? I mean, in fact, he might be actually one of the fainter ones, like fainter than 14th. Could be. So, but yeah, it looks like I can definitely see the 13th magnitude star. And the thing about UV SETI, of course, is that it's only going to get brighter, right? This is about as faint as it can get. So yeah, if I can see it, a 13th magnitude star with a 2-second exposure, then I can easily see anything else. So pretty interesting. I've been looking for a variable star project of sorts, and yeah, I think I found it. I think I found it with.
You can re-explain what you mentioned, building with the buildings for a minute. Are you using video astronomy?
No, this is using a CCD camera. It's an SBIG ST7, and the telescope that you saw behind me, that's a Celestron Nexstar 8SE. So it's just an 8-inch telescope.
Stop sharing the screen and show them the CCTV camera in the telescope.
Let's see. Can I? Yeah, I can grab the camera. Hold on a second. Okay, so I've got the. Let me stop sharing my screen. Come back over here. You can see the scope there behind me. So that's an 8-inch scope, and then here's the CCD camera. And as you can see, it's a. Is that going to focus?
Oh, it's going to focus.
Yeah, it's not going to focus. Anyway, there it is. And I can take the dust cap off, and you can sort of look down in there. Do you see the chip in there? There we go. So there it is down there. It's got a little piece of glass between it and the outside world. And there's the famous parallel port. Yeah, this is sort of an old school camera. but works really, really well.
And not only that, I think you was playing with video with your webcam that you modified as well.
Well, that's absolutely true. It has its limitations though. You know, I'm definitely not going to be able to use my webcam to observe a 13th magnitude star. Yeah, no real chance of that. There's not really even any point in taking a video and then trying to add all the images up. It's just the noise is going to kill you. So yeah, this is sort of the only way, at least that I have access to. But yeah. So I think I'm definitely going to at least take one night to make sure that I can see it, and definitely collect some data, because the interesting thing is that this thing seems to be going off like all the time. I'm going to share my screen again, and I'm going to show you some data that I've been looking at here. Let's see. We're going to go over. Going to go over here. Whoops. Where are we going to go? We're going to go here. So here's a table showing, and this table is a little confusing, but maybe I won't get into that. I'm just going to show you the data that I've got here. You can
and
sort of
this is your data, right?
No, this is data from this paper that came out way back at some observatory in Budapest in 1984. so yeah, no, I
They got my T minus 2 or 3 years that paper came.
But they have
could the way that they have that old camera could be at least part of your tracking issues?
Yes. I'm Uncle Bill, not to get too sidetracked, but my understanding is that my telescope mount is tracking about as good as it can. And what it needs is an auto guider. And with the system that I have, auto guiding is, as far as I know, is not currently an option. So yeah, I mean,
how much is for an auto guider?
Well, an auto guider is a system, right? It's not really just one thing. It's hardware and it's software. What the auto guider does, and here I will stop sharing again, because we can definitely talk about this, but I want to flail my arms around. So an auto telescope like this, right, has a mount, right? So this part up here, right, the orange part, is called the telescope itself, right? The OTA, I forget what that stands for. This part down here, right, is the telescope mount. And in my case, I have a 2-axis mount. One makes the tube go up and down, and then the other axis here makes the tube go left and right. So yeah.
Optical tube assembly, Uncle Bill.
Optical tube assembly. Thank you, Uncle Bill. Thank you. Yeah. So now, sometimes my brain just goes to absolute sleep. What Bill was asking. Oh, right, yeah, about the weight of the camera. So so when tracking, right, what I do is I do a star alignment, and that tells software in this mount more or less how to track the sky. But it isn't perfect, right? I mean, it's pretty good, but it isn't, sub-pixel, right? In order to get sub-pixel tracking, what is normally done is a second small telescope is mounted to this main scope, and that second telescope has a camera as well, and so it is looking pretty much at the same place that the main telescope is looking. And there's a piece of software running that is communicating with the camera on the second small telescope and the telescope mount. And so what you do as a user is you tell the auto guider that, okay, I'm sort of looking at the field of view that I'm seeing, and I want the software to make sure that the mount is always pointed to this star that's in the field of view, right? So keep that star right on those pixel coordinates. And so if the mount tracking goes a little bit off, the auto guider will sense that, right? Because the image of the star will move from the pixel location that you want it to be at. And so the auto guider will send the software this information. The software will calculate how far to move the mount to sort of correct for this bad tracking, and it'll then move the mount. And it does this at a pretty high frequency. You could do it, several times a second if you want. Once or twice a second is probably good enough. So yeah, so that's an entire system. And the problem that I have is mainly the software that I'm using to operate this camera, right? Now, this is an old camera. Oh, okay, this is an old camera. So it can only be run with some pretty old software. And that old software only runs on Windows XP. Does anybody remember Windows XP? So
if you don't remember Windows XP, you got a problem.
I've got a Windows XP right there. Yes. Because without it, I wouldn't be able to run this. And if I can't run this, then there is no reason to live. It's as simple as that. So
I guess keep running XP until your computer dies.
Absolutely. Well, no. Once the computer dies, I get another computer, and I install Windows XP on it. So that's the only
thing you won't be able to do.
There's lots of ways to do that. No, I mean, what has to happen, right, is that I need to put myself into the 21st century and actually get a modern camera. So that'll happen. That'll happen. No worries there at all. So once that happens, right, then I can, I'll just forget about Windows altogether, which is a dream of mine, right?
I think it'd be better if you get yourself a new CCT camera and a new computer.
That is the plan. That is the plan. So yeah, these new modern cameras, in terms of sensitivity, haven't really changed, but in terms of size and download time and all that, look, full frame on this, right, is 765 by 510 pixels, right? So it's tiny, right? Tiny, tiny, tiny. And that
now,
takes...
Can new CCT cameras can do like 4K or 1080p?
There are definitely 4K cameras out there, 4096 both sides. I think bigger than that too. And see, this thing takes, for that small of an image, right? It takes 16 seconds to download those images through the parallel port. So it's just, the duty cycle for this system is absolutely terrible, right? I mean, a 2-second exposure takes 16 seconds to download, right? So it's just like, with USB 3 that they have now, a 4K image takes, I think, just a few seconds, right? Just like bam. So yeah, there's a lot of advantages to doing an upgrade. But like I said, in terms of sensitivity and in terms of quality, I've got it. I just don't have, the big fields of view or anything like that. So I can live with that. I have no problem with that. I mean, when I'm looking...
Imagine about you having gigabit internet and stuff.
Yeah, there's all kinds of possibilities, but one has to not only deal with, but also try to enjoy the situation one is in, and that's what I try to do. So yeah, and this is working really, really great. So yeah, so with this camera, thermoelectrically cooled, right? You can sort of see the inside electronics there. Well, of course, now it's focusing. So here, then it goes out of focus. What is that? There we go. Even got the serial number there too, so you can look that up. CE sticker there. So there's some of the inside guts. There's a fan. It's a pretty quiet fan still too. That's the only thing that...
on and off switch?
There's a on and off switch on the power supply, right? I mean, it's like a AC to DC converter box, There's a power switch on that. Yeah, it's kind of a funky power connector too. You see that? This thing right there?
Yeah.
So yeah, it's kind of a funky thing, but like I said, sensitivity is really, really awesome. It's 16-bit, so it's got a nice large dynamic range in terms of not only digitizing, but also in terms of sensitivity, right? I mean, it can see very, very bright things and very, very faint things. So yeah, so with that kind of a system, right, I can definitely see a 13th magnitude star with a 2-second exposure.
And have a good night, Bill Wink.
Thanks, Bill Wink. Nice to see you. Come back anytime you want.
Yeah. Yeah, I really like the way how we can have health issues in space.
It it's going to be a really interesting next 10 or 20 years, I think. If things keep going, the way they are, I think it's going to be pretty interesting. I mean, pretty much as interesting as the previous 10 to 20 years have been. I think it's going to be, they always say, things are sort of increasing exponentially. So yeah, I think we're going to see the same kinds of, really interesting changes. As long as we don't destroy ourselves, I think it's going to be getting really, really interesting. Yeah, for sure. Let me show you these flares, and then I'll let you go. So here's a list of flare events that occurred at UV SETI over the course of a pretty short amount of time. So here they are, and again, I'm not quite sure. Well, here's sort of the problem that I have, right? Is that they say that so during the 94.25 hours of effective time of observations, 14 flares were detected. Okay. But then if you look at their table, okay, now look, that says 14, right? 14. Okay, well, if you look at their table, here they sort of give a description, right, of each of the columns, right? So serial number of the flare, date of the flare, time of the maximum, the rise time, the decay time, and then the change in brightness in three different colors, three different wavelengths, and then in two different colors, right? 14 flares. Okay. Well, I look at this table, and the first thing I see is that it goes from 1 to 16. And then it goes, 1, 2, 3, 4A, 4B, 4C, 4D, 4E, all the way up to 51 with some multiples in there, right? And then there's another one that goes from 1, here's an 8A and 8B, to 1 to 27. So I'm not really sure how to interpret this table, because they say that there are only 14 flares, but I'm confused. But I guess if we look at the dates, right, and that's sort of what I was doing, it's kind of interesting that, see, on the 2nd of October, 1978, there were 2 flares that happened right after one another. And on the 4th of August, 78, there were 1, 2, 3, 4, 5 flares on that day. So multiple flares in one day. Look at this. Look at all these that happen, and they're not close to one another, right? They're minutes or hours apart, right? So kind of interesting, and there's a lot of them. So I'm thinking that I'm going to have a pretty good chance. I think, if I observe this thing over like a 4 or 5 hour period, the amount of time that it's sort of up in the sky, wow, I might actually be able to see a few of these flares. And is there any scientific value there? I don't know yet. Not quite sure. But some of these are pretty extraordinary, right? So here's a change in U magnitude of 6.5 magnitudes, with a rise time of less than 2 minutes. So pretty amazing. And some of these are fast, right? 4 seconds. Let's see, here's a 3.5 magnitude change in 6 seconds. So these are fast. These are really, really fast. So they rise fast, they decay fast. Sometimes the decays are really slow. It's all over the place. All over the place.
Sounds like an interesting experiment for you to do.
Yeah, I don't know. I don't know where it's going to go though. Because I mean, I'm not really into just sort of collecting information just to do it, right? I mean, I want to do something with it. So, but a lot of times doing something will sort of show you the way. So we'll see. We'll see. But yeah, these changes in magnitudes are, well, relatively significant. I'm sort of looking at the change in V. If I'm probably not going to filter the light much. So this camera is most sensitive at V. And so if we look at the changes in V, they're definitely not quite as significant as like the changes in U or B. But some of these, 3.2 magnitudes, yeah, all of these I would definitely be able to see. I've got an accuracy of about 1/10 of a magnitude or so. So I can see any kind of wiggling down to about 1/10 of a magnitude. So I probably would have been able to see most of these. So yeah, we'll see how that goes. These are just some plots, which yeah, it's kind of hard to understand what all these arrows are, and yeah, I'm not quite sure what that's about. All right, well, with that, I think it is about time to exit this place. So I'm going to stop sharing. And yeah, there's a lot more to see in Cetus. We haven't even started looking at galaxies or anything. I think there's a couple other interesting stars. So yeah, I think we're going to keep on with Cetus for a while. I think one of the nice things, sort of the timely things about talking about the constellation Cetus right now is that it's up soon after it gets dark. So this is an object that can pretty much be seen anytime at night this time of year. So yeah, I think it's sort of a timely thing, and I would definitely. I mean, there are so many really, really neat things to talk about in sort of the context of this constellation. I'm just going to keep going with it. We'll grab some HST images and play with those inside a GIMP. Maybe try to make some color pictures, and yeah, find out more about the myriad of objects in Cetus. It's a big constellation, and there's a lot left. So I think we can definitely do this at least a couple more times, for sure. And, so,
Cosmic, I thought I read somewhere that there was a comet that's in Cetus right now. 46P something or other. I don't have the exact number, but
let me do a quick look over on. Uncle Bill's going to kill me if I don't use CalSky, so I'll use CalSky. And here, I'll share my screen so we can take a look at that together. Let's see. Is it pretty bright?
I don't think it was exceptionally bright. No, I know it was definitely not a binocular kind of thing. I was,
Okay.
needed a telescope, but
Let's see here. Let's see. The right ascension is going to be around, well, between 0 and 3 hours, and I'm looking for. Is it any of these? I guess this is. See, yeah. Uncle Bill, this is just not. This is just not doing it for me. Sorry, dude. I'm going to go over to Heavens Above and go to Comets here.
So 46P Wirwin.
yeah, I put the name in chat.
Okay. It's, oh, let me look. Oh, okay. Huh. Well, you know what? Look at that. It's not showing, it's not showing up, here. Okay, well, let's go back to, Cow Sky and see if it comes up at all anywhere. Oh, there it is. All right, Cow Sky. Thank you. Let's see if I click on that. What does that do? Oh, I've not specified an observing site. Well, I don't want to. Okay, there it is anyway. Okay, so looking at the light curve right now, right, and it's looking like it's maybe around like 11th or 12th or so. Does it say? June, here we go. So 3rd of November, it's supposed to be 10.5. So yeah, definitely not a naked eye object. 10.5 is sort of pushing binoculars too. Definitely a telescope. You'll see a little bit of a fuzz there, for sure. But at least was I? Let's see. These star charts are terrible, but let's look anyway. Okay, here's. Yeah. Oh, okay. It looks like 12th of October. That's right. It looks like it's in Fornax, which I think is just south of Cetus. So maybe it's already moved through. That's entirely possible, I suppose. As I said, these charts are absolutely terrible, but let's pull it up anyway. Yeah.
Yeah, I think I saw that it was heading towards Cetus either the end of August or last month, so it might have gone through already.
Yeah, I'm sort of thinking so, because that is the correct RA, but it doesn't go quite that much south or that far south. So yeah, but
that was the original chart where it was set up, but it was changed when the launch window was missed.
oh,
Well, that's interesting, Uncle Bill.
interesting. Didn't know that one. Uncle Bill knows all kinds of stuff. It's amazing. All right, you guys, I'm going to get out of here. I definitely respect your time. Don't like to go too much over, but man, there's always so much to talk about in terms of astronomical things and space things and all of that. So really glad you came in again. We'll definitely be here tomorrow. I do have a musical gig tomorrow, but it's in the afternoon, so I should definitely be home easy in time. So yeah, don't have to rush or anything. should be home at least a couple hours before the live stream. So easy peasy. But yeah. So gonna be playing with the keyboard over here again, ding, 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 and having a good time with that. And all right, so let's get out of here. I will see you all again on the spin in a little less than 23 hours from now. Take care, everybody. I'll see you later. Bye.